today's topic about depth first search. Um, First step is introduction. In introduction, we are going to discuss what is a depth first search, and I'm going to give some animation with graph. So, depth first search is algorithm for traversing a search tree or graph data structures. And the basic idea of this algorithm to start from the root and move to the um, adjacent unmarked road or node, and then continue this loop until there is no unmarked adjacent node. Time complexity for this algorithm is OV plus E. V is vertices and the E edges. By itself, the DFS isn't all that useful, but we can use this algorithm for tasks like count connected components, determine connectivity, or find bridges, articulation points. So for this, DFS really shines. And here, short animation or example. So let's consider that one is our root node. So we are going to choose path, and it's not important which path, because in the end we anyway we are going to visit all nodes here. So we go to 2, and after 2 we are going to another path, and it will be 4. After 4 we have here just 2 paths like 2 and 5, but we already visited 2, so we are going to 5. So after 5 we go to 6, and so 6 was visited, and here we don't have other passes because all of them was visited, so we are going to return to our way. So before 6 it was 5, so we return, and then we go to 3. Here we have another connection to the 3. After 3 we are going to choose path 8, and after 8 we go to 7, and again we visited all of them, so we are going to return to our way. So before 7 it was 8, and before 8 it was 3, and the same action here. So we go to 5 and the 4 and the 2 and the 1. But here we don't visit the one connection, and okay, it's DFS 3. So and the one connection is 2, and it's our how our algorithm looks like. Second step is about code of DFS. So let's consider at first pseudocode. We have two ways to two ways of this algorithm. It's with stack, and another one recursive. First one is stack. So let's consider in our function DFS we have G is a graph, and the S it's a source vertex. So here we have stack, and we are going to insert our first. At first we are going to insert source vertex, and then we mark as visited. So in we have here loop, which will work until our S will not be empty. And here we consider that V is value in the top of our stack, and we are going to push it. Then we have a for loop for all for all neighbors of this node. So it will be work if they are not visited, and we are going to if they are not visited, we are going to push it to our stack. Then we mark as visited. And in the same logic, we have another function. It's recursive. So recursive is a function when we call our function inside it again. Mark as visited, and we have here for loop. If our neighbors of this of source code not visited, we call function and do until our uh, until it all our nodes will not be visited, and until stack will not be empty. So here I'm going to show it from IntelliJ, and I am going to show version with stack. In my class graph 2, I have int v, its value for number of nodes, and a linked list because we are going to use adjacency list. So here we create our graph, and with function add edge, we add new connections between our vertices, and the main part is our DFS method, which has stack, and with push method we so how it's so we push now we add our node, and here we have loop. While our stack is not empty, we are going to okay, here with these two functions we get our first element, and when after we get this, we are going to remove. Then we I don't know for why this. Then we have our for loop, which get all our neighbors of our first element of our root node, and if they don't visit it, we are going to push this element to our top. So I think it's all. Here we create graph, and I am here insert new values, and call DFS function with source node 0. Let's run it. So 0, 2, 3, 5, 4, 1. It will be my my new graph after dev's first searching. Okay. Examples from real life. Depth first are often used as subroutines in other more complex algorithms like matching algorithm, Hopcroft cut, and tree traversal algorithms. So, and depth first search is a common way that many people naturally approach solving problems like mazes. Here I have short give, where we select path in the maze, and then we will follow it until we hit a deed or reach the finishing point of the maze. For example, here it's X, we finish, so we are going to another way,